to drop your name, affiliation, and location into the chat just so we get a sense of who is joining us this evening. My name is Amanda Cabanillas. I'm the Education and Outreach Coordinator at Greene County Soil and Water Conservation District. This is our third year offering this series as part of Schoharie Watershed Month, and it's been really wonderful to support the evolution of this programming. So thank you all so much for joining us and learning this evening. Schoharie Watershed Month is a month-long series of free community events that celebrate and raise awareness of the waterways that flow across the Schoharie Reservoir watershed, as well as the 315 square miles of land across Greene, Schoharie, and Delaware counties that feed them. Following this evening's program, we still have 4 more Schoharie Watershed Month offerings. These include 2 more Watershed Wednesdays webinars, a kayaking event on the Schoharie Reservoir. That is this coming Saturday, and we actually still have 2 spots available. So if you would like to join, please feel free to reach out to me. And then on Saturday, May 31st, we will have the 3rd annual Mountaintop BioBlitz celebration at the Mountaintop Arboretum in Tannersville. Information about all of these events can be found on the homepage of our website. That is gcswcd.com. These programs are all offered for free to the watershed community and have been made possible by the Schoharie Watershed Stream Management Program, which is a partnership between Greene County Soil and Water Conservation District and the New York City Department of Environmental Protection. This evening's session, Sustaining a Brook Trout Stronghold, Initiatives in the Upper Schoharie, will be presented by Stephen Swenson of the New York State Department of Environmental Conservation. Stephen Swenson received an Associate of Applied Science from SUNY Cobleskill in Fisheries and Wildlife in 2003, and a Bachelor of Technology from SUNY Cobleskill in Wildlife Management in 2005. He has been working for the New York State Department of Environmental Conservation since 2005 and currently serves as an aquatic ecologist within the Bureau of Fisheries. Swenson ran the Protection of Waters program prior to his transition to aquatic restoration, which he's been specializing in for the past 10 years. He is a certified wildlife biologist with the Wildlife Society and an associate ecologist with the Ecological Society of America. This presentation will last approximately 45 minutes, and there will be time for questions at the end. Please feel free to use the chat or the Q&A box to submit those questions. If using the chat box, please just make sure that your chat is set to go to everyone. So that is all from me. I will turn it over to you, Stephen. Thank you so much for joining us.
Thank you, Amanda. It's great to be with you tonight, and it's really a pleasure to talk to everybody about the work that I really love to do, and it really coincides well with what goes on in the district at Greene County, as it does in many other districts. We all have a real interest in protecting our streams, and so it's just great to be here to talk a little bit about specifically trout in our streams and what I do at DEC from my end for our streams in the Upper Schoharie. So I'm going to share my screen and get right to my PowerPoint. Let's see here. Entire screen. There we go. Okay. Just bear with me for a second. We'll get there. So does that look good, Amanda?
That does look good. We have that bar there that asks if you want to stop sharing. Oh, there we go. Perfect.
All right. So I'll get started then. So as Amanda said, I work for the New York State DEC and the Bureau of Fisheries, and I work out of the Stamford office, which is in the Northern Catskills, and I cover all of Greene County as well as 8 counties surrounding Greene County, from the Vermont border all the way to Pennsylvania. So I cover an area about the size of Connecticut for basically all the streams. I'm one day might be working, over in Rensselaer County, and then the next day in Delaware County. But I have spent a good deal of time in the Upper Schoharie over the past several years. So there was a nice brook trout video to start off with, and here's the huck of one of the hucks in the Upper Schoharie. And I show this to you, obviously, because it's in the Upper Schoharie, and that's our topic tonight. But if you look over to the right-hand side of the screen, you'll see a bunch of blue dots on the streams. And those are occurrences of brook trout. And so what this is showing is, why the Upper Schoharie is so important for my work and for the DEC and for whoever else is interested in protecting our native trout. And many of you might be familiar with the new New York State Trout Stream Management Plan, which it's part of that is selecting priority waters to work on from a habitat restoration standpoint. So this is just kind of showing you part of the Upper Schoharie in which I work in, and one reason that I'm there, and I try to spend a good deal of time. You have the Westkill and the Schoharie Creek running through there down to the reservoir, as well as many other tributaries that are very rich in brook trout populations. So before I talk a little bit about the initiatives that are going on and have been going on in the Upper Schoharie from my end, I'm going to talk a little bit about the abilities of trout and what trout can do, and what I've learned they can do over the years that I might not have thought that they could do. Just when I think I have them figured out, they teach me something that I didn't know. And so there's some kind of neat research I've done over the years that I'm going to share with you. Starting with this, I know there's a lot of words in that scientific poster on the left, but don't worry about it. I'm going to explain it to you. And so this is what scientists often will do, is present these posters at symposiums and conferences. And so I put this poster together for the New York State American Fisheries Society meeting several years back. And what I was doing is two different projects on this one culvert, and it's entitled Utilizing Pass-Through and Pass-Over Radio Frequency Identification HDX Single Antenna Systems. So that's one part of it, to evaluate the passability of a culvert pre- and post-baffle installation. So what a radio frequency identification unit is basically an antenna that you put over a stream, and you can detect trout that you've tagged with pit tags. And a pit tag is a passive integrative transponder, which is basically the same thing that your veterinarian would put in your dog or any of your pets. And if that animal gets lost, the vet can scan it, or the dog control officer can scan it and hopefully get your pet back to you. Well, it's the same thing, only we put these pit tags in fish. And so what I was doing at the time was I was making, let's call them homemade RFID systems, radio frequency identification systems, because I didn't have a lot of money to work with, and I was making them for $270 a piece. And if you purchase them, they're in the thousands of dollars. And the time came when I was able to purchase one from a company called Oregon RFID. And so I was curious to see how well mine worked compared to the commercial RFID units. And so that's part of this study, was to test my units. And then the other part was to test this culvert that you're looking at in the right-hand picture, both pre- and post-baffle installation. Now, baffles are these things that you put inside culverts to slow down the water velocity and basically make it so it's easier for fish and other aquatic organisms to pass through the structure. And so it's a two-part study. And so moving forward to show you what we found, if you look over on the lower left-hand side, those are baffles, those blue plastic pieces. What we found out is that before even we were installing those baffles, during the years of 2018 and 2019, we had trout movement already going through that structure. So I had a feeling that it wasn't a complete barrier to trout. But what I found out using these RFID units was even more interesting, and that's, it depends on the flow, and every single culvert and every single bridge structure or potential barrier to trout, it's variable, and they're all unique in their own way. And with this structure, trout, and in this case, rainbow, brook, and brown trout, were able to pass through this structure when the flows were between 0.55 feet per second and 3.4 feet per second. And if you focus your attention to the right-hand side of the screen, the red bars on the x-axis, basically in the middle of those bars show a sweet spot in which those flows are just right for those fish to move through the culvert. So too low, not enough flow, and too high velocity. And so what I'm getting at, and what you'll see a theme in this presentation is that, and I'm a firm believer of, I don't call a culvert or anything a barrier until it's proven to me by the fish that it is indeed a barrier, because I've been fooled. And it's kind of funny. Again, I'm always learning from these fish. So getting to the baffles again, I didn't continue this study to test post-baffle installation. This was the first part of the study. And the reason being is when we got these baffles from a company called ATS Environmental out of New Zealand, we installed them and they just did not stay put. The streams in the Catskills are too high grade and the velocity is too high. And so that's why this is really showing you before I even installed the baffles. And I want to point out that one of the reasons I was looking into baffles is because at the time there wasn't a lot of money for complete culvert replacement for barrier removal. So the thought was that we would put these baffles in all over the place and make it easier for fish to pass. Since then, there's been more money, at least for the time being, for complete culvert replacement, and I'll get into that later on in the presentation. But it's very cool. In this case, again, the fish can move during those flows. And the next slide here shows you why I didn't continue with these baffles. They just did not work the way I'd hoped, and they were installed to spec the way that I was instructed to install them, and they were extremely high maintenance. So we learned really what we needed to learn is that we weren't going to proceed with the baffles, but in the process, I learned that my radio frequency identification units that I was testing worked quite well, and I learned that this was certainly not a barrier to fish, and that during certain flows it was, but during certain flows it wasn't. So there are ideal flows, and that's something to keep in mind with any structure, any culvert, or any kind of potential barrier to fish. It might be a barrier sometimes, but maybe not other times. And so I have a little YouTube video. I'm going to hope this works out for you on this particular one that I'll play quick.
Hey, Steve, are we supposed to be hearing the sound on that, or does it not matter?
Are you not hearing the sound?
No, I'm not.
No.
At least I don't
Okay.
know.
I'm not sure if I know how to correct that. Maybe what I'll do is I'll move on and we can share the link to this video if that works.
Sure, yeah.
My apologies. I usually am doing this live and I'm not exactly sure how to make the sound work. So I guess I'll move forward. Basically, the video was just talking about everything I told you, just showing it more or less. And so if you're interested, we can share the link and you can look that up. Oop. All right, let's go to the next slide here. All right, so here's another scientific poster that I put together for another conference, another American Fisheries Society conference. And again, don't worry about trying to read it. I'll explain it all. And it was entitled Evaluation of a Bedrock Fall's Potential to Serve as a Barrier to Fish. And so if you look over on the right-hand side of the screen, you'll see that perched culvert, like so many others, perched in the air and just kind of an old structure under a town road. And the town approached us and asked us to help them replace it. And so we did. And we were applying for what's called WQIP funding, which is Water Quality Improvement Program. It's a large program that DEC has, where we fund culvert replacements and all sorts of water quality projects around the state. It's a pretty significant fund. So we were applying for that money with the town, and Trout Unlimited was a partner as well. And we, in the process, when you're doing this kind of work, you have to survey the stream, and you have to survey to find the longitudinal profile of the stream. And about 80 feet downstream of this culvert, we found a bedrock falls. And so we said, you know, it's going to take some time to actually do this and implement this structure and build it and everything. And so let's study it a little bit while we're here. Maybe once we're here with a machine, maybe we want to, you know, try to do something about that barrier, or maybe we don't. And before I go to the next slide, you'll see the lower photo underneath the perch culvert. That's the replaced structure. So that's the new structure that we put in. Again, Trout Unlimited. Oh, and U.S. Fish and Wildlife Service was a partner on this as well. And there's a grade control structure beneath it that helps step it up to the culvert, and also hold the grade of the stream in place where we need it to be. So here's the bedrock falls over on the right-hand side on the lower right-hand corner. And this is a prime example of me as a fish biologist. I went and I looked at this and I said, this absolutely has to be a barrier. But it didn't turn out to be a barrier once I studied it. And so this is a brook trout stream, only brook trout. And we did basically the same thing that I showed you earlier at the other culvert. We installed a radio frequency identification unit, which is basically an antenna that went across the top of that bedrock right where she's standing. We put an antenna, and then we pit tagged the fish, again with passive integrative transponders. But we also clipped the adipose fins of the fish for the reason being that we wanted to see not only if those fish went up through that antenna and were detected, but did they continue and go up the culvert? So is the culvert really a barrier? And in the end, we learned that the bedrock falls is not a barrier, and that the culvert was not a barrier, or was a barrier, I'm sorry. It was a barrier until we replaced it. So the bedrock falls is a barrier. The bedrock falls was not a barrier. The culvert was the barrier. So, pardon me for that. So if you look over at the left-hand side of the screen, you'll see there's some weather data from the Bovina Weather Station from July 25th and 27th. And those are just two examples that I chose to use of storms that occurred. And what happened is these storms occurred, and 12 of the fish that we pit tagged were detected, and 9 or 75% of those fish moved directly following a rain event of greater than 0.175 inches. And so I chose these two particular storms at this weather station because they really correlate well to the hydrograph below on the Little Delaware. And so it shows those two storms and the fish movement directly after the storm. So what you're looking at on that weather station data is the orange vertical lines are the fish moving, and the green line that goes horizontally is the storm. And so it was just incredible to me, and I went out and I didn't expect to get any data off this, and I opened up my laptop and I plugged it in. And you can see that on the right-hand side of the screen. And for somebody like me, it's like Christmas morning. I was just so surprised and just excited to see that brook trout, not only brook trout, but little brook trout, smaller brook trout, passed over this big bedrock falls. And I always figured that they had, you know, the ability to do that to some extent. But this is a very vertical drop. And I was really surprised to see that was the case. So I took a picture of it to show you, and you can see the data that was downloaded on my laptop screen. And I couldn't wait to get back to cell phone service to call somebody and tell them, somebody else that would be just as excited as me to see this. And so in the end, we didn't do anything with these falls. We left them where they are, and you know, maybe potentially in the future they might act keeping other things out that we don't necessarily want up there. But the best way to explain this and why the fish moved over these falls, but they did not move through the culvert upstream that you see in the previous slide, is is if you envision a garden hose and you turn the hose on at full pressure and you put it over a table, let's say your patio table, the velocities coming out of that hose are significant, very high. And if you take that hose and you pull it back over the table, the velocities slow down and they spread out. And in this case, that would be the bedrock falls. The flows are spread out versus going through the culvert where they're confined to that culvert. And what they do is the velocity is slower and the water column increases when that flow is increased. So that's just enough to basically step the water level of the stream up higher and allow those fish to move under those conditions. And so again, it's just an example of these trout, have evolved, and they move during certain weather conditions. And again, I think we all know that to some extent, but it's always surprising to me just exactly when we can pin it down for their movement. That's not to say that we shouldn't continue to replace barriers whenever possible, perch culverts and things of that nature. But I find it very interesting that they're able to move over some of these what you would call a barrier often. So some other things that I've experimented with regarding trout abilities are culvert ramps. And so again, this is back in the time when there wasn't a lot of funding available to replace culverts. We were playing around with these culvert ramps, and they also have another application aside from just a permanent use. Because if you look at that picture on the left-hand side of the screen, that's not something that screams permanent. What you might use this for is if you have a perch culvert and you have a trout population upstream that is petering out because there's no genetic mixing going on. You might decide to put this culvert ramp in a culvert and allow fish to move upstream for a couple of years, and get your fish upstream so that you're not basically having a problem genetically speaking. And this worked. This was a partnership with SUNY Cobleskill. We're actually in a partnership with them as well currently, and as is Greene County Soil and Water Conservation District, to look at another kind of culvert ramp. And you see in this, it's basically an HDPE culvert pipe that's cut in half, and baffles, just like you saw earlier. They're a little bit different, but they're baffles that are installed on the invert or the bottom of the ramp. And this particular stream is a tributary in Gilboa to the Platterkill. And in this case, there were no brook trout upstream of this culvert. And so we set up RFID units. You can see her in the stream setting up a pass over antenna. That's one of the antennas that I built in-house, one of my homemade antennas on one of my RFIDs. And we tagged a bunch of fish, and we put them back in the stream, and we put that antenna upstream of the culvert, and we put one downstream as well, so we could see potential movement in terms of back and forth potentially, upstream and downstream. What we found is that they moved upstream, and they went up and over that culvert ramp, and they continued further upstream. So this is kind of another tool that can be used if you have, again, maybe heritage trout, a population that you're trying to help, and that culvert might not be replaced, in the foreseeable future. So you might put these in to try to help the genetics of a local population of trout that might be petering out. So I'm going to transition over to the initiatives going on and that I've been part of, as have many other people and partners. And these initiatives are all partnerships. I can't think of one project where I'm not partnered with another group. And as I mentioned, Greene County Soil and Water is one, and there's been several of those in the past, and as is Trout Unlimited and U.S. Fish and Wildlife Service. And so I'm going to start talking a lot about culverts, and that's because they're super important to our brook trout and our trout populations as a whole. And people drive over culverts on a regular basis, and sometimes tens, maybe hundreds per week, and they don't think about it. And they don't necessarily think about how culverts can fragment an entire ecosystem, and not even just an aquatic ecosystem, but a terrestrial ecosystem. And the monetary impact of road collisions, for example, if you're talking even terrestrial species, mammals, large mammals, out west, for example, they're putting in crossings just for wildlife, and in the end, it actually saves money. Your insurance rates, for example, and roadside collisions with vehicles and large mammals are very expensive. Those signs they put on the side of the road don't do anything. The deer don't listen to them, of course. But I learned something recently while reading this new term that I'm starting to see a lot, and it's called road ecologist. And I said, I guess that pertains, quite a bit to myself and to many of my partners, because I do a lot of culvert replacements with my partners. And so anyway, this is what most people think of, these culverts that you see in front of you, when they think culvert. But there's a lot more to it than just these round corrugated pipes. And so when I'm working with my partners to replace a culvert, we have a culvert assessment and prioritization process. And we do this to make sure that we're spending funding appropriately, and that we're doing projects that are going to have a large and significant and long-term impact. And so some of those parameters that we look at are aquatic organisms. So if we have a stream that is loaded with trout or eel or something that is significant and important to the ecosystem, we're going to probably score and rank that project higher versus a stream that has nothing in it, because we do have plenty of streams that have nothing in them. Funding opportunities, if there's no funding available, well, we're probably not going to be in that geographic area. Hydraulic capacity, every culvert that we replace is going to have an appropriate capacity, and it's a 100-year storm. Municipal priorities, we want to work locally with the towns and the counties, and what do they need? They probably have a list of culverts that are problematic and that they would like to see replaced, and in all likelihood, those culverts are going to correlate with your objectives, or whoever's working on the project. You can usually find something that is going to basically fit the municipal priorities category. And even if it's not going to fit something they want to see replaced at that point in time, once you replace these, they're very long-lived structures, and they won't have to worry about them for a long time. The passability of aquatic organisms is very important for obvious reasons. Structural integrity, a lot of structures are pretty deficient. If you were to take a drive around and get out of your car and look at culverts, you might drive a little bit faster over the structures that you're seeing, because a lot of them are in disrepair, unfortunately, and so that's important. And then threats, things like flooding. And so I mentioned funding opportunities. I'll wait to talk about that in a minute. I'm gonna talk about how what tools we use to prioritize culverts and projects for aquatic connectivity. And so those of you who aren't familiar with NAC, that's the acronym we all use in the field to describe this. It's the North Atlantic Aquatic Connectivity Collaborative. And basically, states from the Mid-Atlantic all the way up New England to Maine are using this protocol to identify problematic road stream crossings. And then they get put into this database. And what you're looking at on the right-hand side of the screen is New York State. And it's got to be updated. This is a slide from several years ago, but those are all NAC assessments. And so it allows any practitioner or somebody that wants to look at a culvert to go on their computer and access this database and find any culvert that's been assessed through this program. And so it's a really great tool, and one way that we start our prioritization process for culvert replacements if we're in a given geographic area. So that's where I'm getting to funding. So for example, with the Upper Schoharie, which is obviously the topic for this evening, I knew I was going to be working the Upper Schoharie for several years, and because funding was available. So my partners at Trout Unlimited and DEC, we basically hired some technicians to go out and do NAC assessments on all these culverts in these towns on the left. We set out to assess 607 culverts, and the technicians assessed 1,184 culverts. And you know, it cost $41,000, but in the end, the data and the information that we gain from these NAC assessments can be used in perpetuity as long as the database is maintained. Anybody can use this data, so I think it's well worth the money, and we've been using it ourselves. So here's what it looks like when you actually zoom in on a municipality. We're going to use the town of Conesville here. You have all these dots, and the red dots are the severe barriers. So I can look at the town of Conesville and say, well, let's start looking at those red dots. And if you click on those red dots, you get this information. So these are some of the NAC parameters, things like inlet grade, outlet drop, physical barriers, constriction, water depth, scour pools, etc. Then you also have the ability to look at pictures of the actual culvert itself, upstream and downstream of it, the road. If you're planning a project and you're looking to replace one of these, you know, you're going to go out and ground truth and look at all this anyway, but it gives you a good idea of what's going on at a site to have all this information ahead of time. And again, you're still in your prioritization process. So having this when you're doing your desktop evaluation is very helpful. If you were to zoom in on the parameters, you would see that this particular example I'm using, it gets scored and it also has basically an evaluation of a severe barrier. So that was one of those red dots that we zoomed in on and used as this example. The other chunk of information that I use on a regular basis is the data from the Eastern Brook Trout Joint Venture, which was basically DEC going out and sampling every road stream crossing in the state back in the years of 07 to 11 to see what trout are out there. And so here's an example of what that data looks like for Region 4. I was talking about my area of coverage earlier. And even though I'm housed out of Region 4, for DEC, I'm one of the few people that actually does this kind of work. So I do consult statewide on projects, but this is my home territory. And what you see there is not just brook trout, but brown trout, rainbow trout, and no trout occurrences in Region 4. So I can go to this database. That's what it is. It's an Excel database. And I'm sorry, it's Access database, and I can check and see if a stream has trout. And if it doesn't have trout, well, maybe I might not focus my attention on that particular stream. Maybe I will. It all depends, but it's not going to score as high as a stream that has, say, brook trout in it. So I'm going to start showing you just some examples of some road stream crossings and culvert replacements from the past couple of years. You'll see that this particular culvert's perched like pretty much every other one you're going to see. And it's on Briggs Road in the town of Conesville in Schoharie County. And what we typically do is we pull out the structure and we replace it with a 3-sided structure. And the other common theme you're going to see is a 100-year storm is what we're going to replace the culvert to handle. In this case, we reconnected 1.39 miles of spawning habitat. And due to limited funding, the town was unable to replace the structure. So it was replaced in 2023 at a cost of $237,000. And you can see why the towns often don't have this kind of ability to replace these structures. And if you do it correctly and the way that the DEC, for example, wants you to do it, it can be quite costly. And so we're always happy to help the towns whenever possible. But they're expensive. Here is the finished product, pretty much finished. There's no guide rail put in, so that happened afterwards. And what you see here is a structural plate arch, which is a very common structure that we use. And what you have to do is you dig out the old culvert, you put in a temporary road, you You pump around while you're working so that you're not working in the wet, and you dig down real deep and you build forms and you put rebar on those forms, and then you pour concrete, and then on top of that concrete you bolt this structural plate arch. The other thing you're doing is you're putting in grade controls. So whenever we survey a stream, I mentioned we do a longitudinal profile, and we figure out where we need to put essential grade controls. So when you remove a culvert that has a bottom, you're basically removing something that's holding the grade of the stream in that elevation. And so if you just pull that out and you don't put in grade controls, the stream can basically downcut and in size. And what that could do is undermine your footings, and you don't want that to happen. So we build grade controls through these structures, and we do our best to blend them in with the natural stream bed. And then the next slide, I think, will show you, well, the next culvert project will show you a little bit better of a shot of what it looks like when it's completed. We try our best to make it look like we were never there and it was natural. So the next example I have is also in the town of Conesville, Calkins Road. And again, you'll see this common theme of we replaced it with a 3-sided structure to convey a 100-year flow event and reconnect 2.4 miles of stream. These are both trout streams. All these are trout streams that I'll be talking about. And in this case, brook trout. And it was replaced at a cost of $260,000 in 2023. And if you look at the structure, it was likely replaced after Hurricane Irene. It's a very substandard product, and it's not that the town's fault. They probably just didn't have the money to put anything else in. It's probably one of these structures where FEMA didn't come through with funding or something happened regarding that, but it's severely undersized. It's a small HDP pipe with some gabion baskets as a head wall. And, I speculate that if we had another large storm event, this would have been gone. So anyway, we work with the town, and I have to give credit where credit's due. The town of Conesville was wonderful to work with, and we very much appreciate them working with us on this. And I'll also mention these are also partnership projects with Trout Unlimited and U.S. Fish and Wildlife Service, this culvert and the previous culvert. So here's the final product, and what you should be looking at in that stream bed is what looks like a natural stream bed, and that's what we're shooting for, is it to look as natural as possible with those grade controls I discussed earlier. You have a nice guide rail that was put in upstream. You have a structural plate arch that's appropriately sized. There's some riparian plantings, and the other thing we did at this site that was kind of nice and worked out well is the Conesville Fire Department didn't have a lot of locations to pull water from, so we put in a dry hydrant here, and we brought the pumper truck down and parked it right next to the dry hydrant, which we put in a nice parking spot for, and it worked quite well. And so the fire department was happy, the town was happy, we were happy, the brook trout were happy. So here's another one on Spruceton Road going south down to Greene County, town of Lexington, another fantastic town to work with. This structure had blown out several times over the years. This is the only way to get up to the Hunter Mountain Trailhead. Plenty of people probably had driven over it over the years, and it was just in horrible shape. And the town of Lexington asked us if we had any funding, and so we did. And we replaced it with another 3-sided structure to reconnect 0.5 miles of spawning habitat. This is a direct tributary to the Westkill, and it cost $121,000 and was completed in 2022. There's the finished product, and again, it's another structural plate arch on poured-in-place foundations. Here's another one in the town of Lexington on Truesdell Road, and you can see obviously it's perched, and in this case we kind of figured it was a definite barrier, because when we electrofished this site, we found no fish upstream. And so this is usually where I take the opportunity to tell you what we do is 2 years pre and 2 years post construction, we do evaluations of the stream, electrofishing, to see if our projects are working and how they're working, and even basically get in there and just see what's going on every year with the fish will really tell you a good story of how successful you were. But this is my favorite kind of success story because there were no fish upstream, and we have this more often than you'd think. And when we pulled this culvert out and we replaced it, the fish move right away. It doesn't take long at all. I mean, we're talking a matter of, hours to days, and those fish are likely moving upstream. But so yeah, this culvert was replaced, cost $189,000 in 2022. It reconnected 1.2 miles of upstream habitat. This is a tributary to the Little Schoharie. No, I'm sorry, the Little Westkill. Let's see here. Truesdell Road. This is the final product. And we didn't go with a structural plate arch. We chose a beefier structure in this case for several reasons. But what it is it's a concrete box beam bridge that was built by Diego Timberlands in Maine in pieces. And so we trucked it down and 4 truckloads from Maine and put it together on site. This takes some more machinery. You need 2 excavators, one to lift the pieces and one to maneuver them in place while your laborers are putting it together. And so some more machinery takes a little bit longer to actually get the pieces together than to bolt the structural plate on. But at the same time, it takes longer to pour the foundations for the structural plate arch. So you'll see some grade controls that were put in. This is directly after the structure was installed, again, to basically hold the elevation of the stream bed where we want it and to allow the fish to pass up through the structure. And as soon as this was replaced and we went up in there, the fish were not only upstream of the structure, they were in the structure. Underneath the bridge where there's shade, the trout really like that. It actually makes quite good habitat for trout. So moving away from culverts for the remainder of the presentation, and I talk about a few restoration projects that this one was just completed, and there's another one I'll talk about that'll go on this summer on the Westkill. This is the Wolf Road Stream Restoration Project, and this is a pre-construction photo. It's a braided stream channel, and you can see some heavily eroded banks on the left side of the stream. And what you can't see is there's a house near that telephone pole that's very close to the edge. And so we thought we'd put in a series of grade controls and habitat enhancement features to both improve the stream stability as well as install some habitat for fish. And so here's what that plan looks like. This is a partnership with Trout Unlimited. Also, U.S. Fish and Wildlife Service was part of this one. And so there's several J hooks that went in the stream, and those basically are meant to kind of protect that bank on the left side of the stream, and it puts the channel where you want the channel to be. And we put in some converging rock clusters that is strictly for habitat, in this case for trout to use for habitat purposes, and then some root wads as well. Root wads and wood in general are fantastic for streams. You cannot go wrong by adding more wood to a stream as long as it's not going to mess up a culvert or break something. So if you put wood in a stream, it's great. You just don't want to put it upstream of a culvert, for example. So we do it a lot. So here's the Wolf Road Stream Restoration post-construction. It's green because it was hydroseeded, but we also put down seed mixes as well, wetland seed, and then pollinator mixes. And there was a repair and planting that went on. And this was like basically the day after we completed the project. It has since grown up, and our plantings are doing quite well. This here shows some of the structures we put in. There's a root wad on the left-hand side of the stream, and on the right-hand side is a converging rock cluster. This structure is what the trout really need, and they're lacking because a lot of our channels have just been manipulated and don't have the structure that they require. So that's some of the stuff we put in here on this job. Here's the repair and planting that went along with it. Partners on this, some of those folks are pictured, are from DEC, Greene County Soil and Water Conservation District, Westkill Brewing. You can see Mike, if anybody knows him, he's on the right-hand side of the picture. And then Trout Unlimited, of course. And so we did some plantings, obviously, in the construction site. and adjacent to it, but then we also did some riparian buffers, as you see in the lower right-hand picture. And I checked on the plantings the other day, and they're doing quite well. So what we're doing this summer on the West Kill is at the Spruceton Inn. It's the Spruceton Inn stream restoration. Basically, there's a whole 300-foot reach of stream where the bank is eroded and the stream is braided. And this just went out to bid, and we chose our bid, and we're going to try to get it in there in August to do this job. And it's 280 feet of tow wood, and I'll explain what that is in a minute, as well as some in-stream rock structures. There's a straight vein at the lower end and then a converging rock cluster at the upper end. So this is what the site looks like now, and you can tell it's obviously not ideal. Whenever I electrofish this site, and I've been doing it for the past 8 years, I've been collecting data on the West Kill, both temperature and fish data. We never find fish here, and that's for obvious reasons. It's exposed to the sun, and they do not like that. If you go right upstream, it's loaded with brook and brown trout, just right upstream of here. So it's horrible habitat, and what we're going to do is put in this, and it's a tow wood structure along the bank. You can see a plan view typical drawing on the left-hand side of the screen, and then on the right-hand side is one of the jobs we did. I don't know if it was last year or previous year. Again, also partnership with Trout Unlimited. And so that shows you what it is. Fish love wood. They love it. And so just getting more wood in the stream while stabilizing a stream bank is just a really great thing to do. And whenever possible, we do it. It's not always possible, and sometimes you need rock. But in this case, we're going to use a tow wood structure. Okay, I'm getting close to the end here. I'm going to talk a little bit about Hunter Brook, which is one of the more important tributaries of the West Kill, and DNA analysis that we conducted, and some pool diggers we put in with Greene County Soil and Water several years back. So on the left-hand photo, you can see one of those beautiful brook trout. They have that dark back, the dark coloration, absolutely gorgeous fish up there in Hunter Brook. And this is the trailhead to Hunter Mountain, so this comes right off the backside of Hunter Mountain, the stream. After Hurricane Irene, the stream was really in bad shape. So Greene County Soil and Water Conservation District and myself at DEC, we partnered and we put in some of these really cool pool diggers that are still in there, and they create some pools just out of wood. And so the brook trout DNA analysis. So the purpose of this was to figure out if there was any signs of mixing with stock trout strains. The samples were collected in 2020 and sent to the University of Albany. And the primary research objective of this project was to characterize the Hunter Brook and Oxclove brook trout populations relative to a previously described native brook trout population and heritage brood strain population. So like basically to see if there's any mixing going on genetically of these fish. And both populations are genetically unique compared to other native New York streams. And if you look at the upper right-hand side of the screen, you can see in orange is Hunter Brook, which is what we're talking about now. And orange is used to show Hunter Brook trout. And if you just go below that, you'll see all of the different strains are separate, and so they're not mixing. So you can see the orange is not mixing with the blue or the green, and so that's really awesome. And we do have plenty of these streams in New York, but they're still very important and they're critical. And we need to make sure that they're protected and that we continue to try to help those fish out whenever possible. So I'm on my question screen, but before I get to that, and the sound might not work in my video after this, but that doesn't matter. It's just the sound of a stream. Even though it's beautiful, it'll drive the point home that I'm trying to make, just the video without the audio. And so I took this picture a week before we finished the project. This is on Truesdale Road, and it's a complete mess. And my point is that, you know, you have to break streams and in order to fix them sometimes, and it can be quite a mess. And when folks see this kind of stuff going on, they have to understand that most of the time it's being overseen by folks that hopefully know what they're doing, like Greene County Soil and Water, like DEC, like Trout Unlimited, like Fish and Wildlife Service. And these excavators are significant. They're important. And the operators that that run these machines, you get a good operator, they do fantastic job at fixing our streams. And so 1 week later, I'm going to show you what this looks like. It's not perfect by any means, but it's still recovering. And you can see that we just finished up our in-stream construction, and guide rails were obviously put on after this. And if you go back there today, you wouldn't even really know that we were there not so long ago. And so that's what I have. So I'm going to stop sharing. Does that work, Amanda? Okay. Yeah, there we are.
That was great. Perfect. Thank you so much.
You're welcome.
So we did have 2 questions come through while you were presenting. The first one here, the historical differences between brook, brown, and rainbow trout. Centuries ago, before humans started introducing these species to waterways and lakes, did rainbow or brown trout prefer living in lakes or streams? What about historical brook trout habitat, streams or lakes?
Brook trout for sure, streams. And in all honesty, I don't really know how, the details of how browns and rainbows evolved, and they're not native fish either. I mean, I would say streams in all likelihood for both of them. You see steelhead, for example, and some of the larger tributaries to the Great Lakes. These fish get huge, and given the opportunity to grow in the proper stream system, they all do quite well. The Delaware tailwaters are a premier fishery in DEC's Region 4, and some of our brown trout down there get absolutely huge. And so my understanding of all 3 species is that they do quite well in streams, and not necessarily, they can live in ponds. It's not that they can't, but their preferred habitat, I would say, are streams and rivers. In Region 4, for example, we have 2 brook trout ponds that we have natural reproduction of brook trout in Delaware County. And you have to have certain factors that lead to that. You have to have very cold tributaries leading to those ponds. And in the Adirondacks, there's several examples as well. But you need basically these ideal circumstances in those kinds of waters where you have cold water streams and you have proper substrate for spawning, because that's part of it too, is with the streams and rivers, you have that ideal substrate for spawning. But getting into the actual history and the historic evolution of the trout, I'm certainly not comfortable speaking directly to that, but so I hope that answered the question appropriately.
Thank you. Yeah, if there's a follow-up question, they can just drop it in the chat. The other question that came through, it looks like, Doug says, thank you for your answer for that last
one. You're welcome.
So this next question, it looks like you're not only benefiting trout, but many other aquatic and terrestrial organisms by maintaining the stream gradient. Could you tell us about how other organisms such as salamanders and darters benefit from these structures?
That's a great question, and I often try to mention more organisms, and sometimes I remember to mention them, and sometimes I don't. That's a great question. So turtles, or another one, wood turtles, are super important, and they're also in the same streams as these brook trout that we're talking about. Salamanders, of course, and these crossings, when they're installed correctly, do allow for the passage of those herps as well, those reptiles, those amphibians, and in fact, some of the structures we've put in over the years, the actual footings that we use, I've seen used by turtles. And yeah, again, wood turtles are something that I think we all forget exist in our streams in Greene County. And as a matter of fact, unfortunately, they're not doing overly well, and they're likely to be listed by the U.S. Fish and Wildlife Service. So not only is this great, these projects great for fish, they're great for for everything that we want to get through. There are certain circumstances where you might have a certain species of fish that you might not want to pass up through to, say, a stream that is populated by brook trout. And so that's why we do these pre-construction, pre-design, whatever you want to call it, biological surveys. So if we find that we have something we don't want moving, we might not necessarily take the same course, but that generally doesn't happen. Most of the time we find that we want to replace the structure, and overall it's beneficial. But it's a great question. And road stream crossings and the anthropogenic impacts of people with those road stream crossings is significant. And there's a book that just came out called Crossings. And if anybody's interested in this topic, it's a great read, and I would highly recommend it. And you'll learn everything you ever wanted to know about road stream crossings and just road crossings for any fish and wildlife.
Do you know who wrote that book?
Offhand, I'm drawing a blank. I have to get that to you. I'm sorry.
Okay. Great. Another question came through. This person says, I would like to have you come out and consult. There is a local stream that used to have rookies, but no longer do. Tell me why.
Yeah, that's a good question. I've seen a lot of that. And I've also seen a lot of streams that have historically been brook trout that are now populated by brown trout. The temperatures are warming. The Westkill, as I've spoken to, I've been collecting temperature data for 8 years now on, and the Westkill is warming too. And so the best answer I can give is that water quality doesn't necessarily just come down to what we often think about, like turbidity and sediment. For trout, the more important part isn't even that, it's the temperature. And so what I suspect is happening in your stream and all too many streams is that the streams are warming, the summers are drier, and I've seen that on the Westkill with my thermographs that I just mentioned. I've never seen the Westkill get as hot as it did last year and the year before, and it's hopefully won't be that way this summer, but that trend is occurring. And again, water quality, I feel like temperature is often left out. The biggest influencer for trout health and trout population is the temperature of the water, not even necessarily turbidity. You can rip apart a stream and make mud, and you're not going to kill the whole population of trout. If you warm that stream, temperatures are immediately lethal. So that would be my guess, unless perhaps it was disconnected from the larger population. And then eventually what will happen is that the upstream populations will die out due to a lack of genetic diversity. So that's the other possibility.
Thank you. That person followed up with, yes, I think I need to cold water release my lake.
Yeah, that's why the Delaware tailwaters are such great brown trout fisheries, because of the New York City reservoirs and the cold water releases.
I think I have a follow-up question to that. It just made me think of Walt Keller.
Yes, Walt.
And his groundwater, his fight to protect groundwater input. Do you look at groundwater inputs when you're designing a stream restoration project?
Yeah, and it's funny because Walt often mentions that, and we look at it, and we have almost every project. And I started doing it with something called DTS, distributed temperature sensing, which are fiber optic cables that you run down the stream bed, and it can give you a longitudinal profile of the temperature of the stream. And it's super labor intensive, but we were using it again. When I say we, it's mostly TU in this case, to an FUDR, Friends of the Upper Delaware, were part of that. But we would pinpoint locations with groundwater upwelling and put structures in those locations. But now we have drones, and drones do it far easier, far faster. And so I have an example project right now that I just submitted a permit for on the Skinevus Creek in Otsego County, where we're putting in wood, lots and lots of wood. And we targeted that location because TU has a drone, and they did a flyover. And we're putting that wood and those boulder clusters right where the cold water influence is. So Walt is correct, and he's very good at continuing to preach that, and I agree wholeheartedly. And we are practitioners of what he's saying.
Excellent.
Yeah.
Love to hear it. I'll have to play him that recording.
Yeah. Yeah. No,
So,
I've known Walt a very long time. He's a good guy. Yeah.
excellent. So this next question, I know warm water contains less oxygen. Is that why trout die in warm water?
Yeah, that's part of it. Yeah, for sure. Yeah. That would probably, yeah, I would say that's probably a good half of it. Yeah. Yeah.
What's the other half?
Yeah, I'm not exactly sure like what goes on aside from that, but that I would say that's probably the larger part of it is that, yeah, is the dissolved oxygen. Because even if you have colder water that's conducive to trout, and you have a low DO, dissolved oxygen rate, that is often something that we see coinciding with the lack of a population. And I'm trying to think, what comes to mind is, there's some streams in like Albany County that we see some higher, lower dissolved oxygen rates. But yeah, I'm not sure, to tell you the truth. I'll have to look that up when I get off the call with you. But it's another really good question. I apologize, I don't have the answer to it.
That's so good. So we have one more question that just came through, and I think probably wrap it up with this one. This is John saying, why are not all reservoirs all cold water released?
Oh, okay. I think I understand. So, what that might be referring to is, like, for example, the Schoharie Reservoir for many years didn't have a cold water release because it wasn't functioning that way, and it had to do with the valves and the whole system in place for those releases. And like the Cannonsville, for example, it has that ability to release cold water, and the cold water comes from the bottom versus the top. The water is going to be warmer on the top. So I think that's what he's referring to. And so I think I would say it comes down to the design, engineering, and functioning of whatever dam structure is at that given location. And there's a lot that goes into those releases on those reservoirs that New York City controls and operates. And there are constituents and meetings and discussions that happen all the time that I think a lot of people don't realize, to try to figure out what appropriate flows are supposed to come out of those reservoirs to both maintain the drinking water supply for New York City, as well as a good flow regime downstream of those dams. But it comes down to the structures themselves as to why they might not be able to have a cold water release.
Got it. Yeah, John, if that answers your question, let us know. I have one actually last question.
Okay.
Here. So at a recent Slack meeting, someone asked about the pit tagging and what happens if waterfowl consume the fish that are pit tagged. Are they able to pass that pit tag? I couldn't answer that question. So.
Yeah, they do. And that's another good question, right? Because people fish and catch fish and want to consume fish. And so there are multiple ways to tag those fish. And if we're tagging fish that we know are consumed, we basically do what's called a cavity tagging. So it's basically in the body cavity of the fish. So you're not going to consume that part of the fish. And believe it or not, the fish are quite tough, and I'm sure it hurts them, but it certainly doesn't kill them or permanently harm them. But if a bird were to eat them, or even a human accidentally, it would pass. But we take every effort to avoid that from happening. And again, if we're in a stream where we know that fish are going to be consumed, we do body cavity tagging, and there's actual scientific rules that we have to follow for when and where to do that, so that we avoid any kind of possible consumption by people. But birds will pass it, people will pass it it's kind of funny. It's actually just a little glass thing about the size of a pill, and they they can be very small, and then they're basically 10 all the way up to 23 millimeter are what we use. So they're not all that big. They're like the size of any kind of over-the-counter medication. So like it wouldn't be the end of the world, I don't think, if unfortunately that were to happen. But we take every protocol we can to avoid that from happening. So
Great, thank you. Now I'll
You're
be able to answer that person in the future.
yeah, it would pass right through them for sure.
Great. Well, those are all the questions. That's the only question I had. Thank you so much for this presentation, for taking your time to join us. This is really excellent to listen to, and I appreciate your work.
Oh, it's my pleasure. Thank you so much for having me, and I just want to thank the Greene County Soil and Water Conservation District. You folks have always been wonderful partners. I've been working with Joel for I think 20 years this May. I've known him, and I'm just thankful for the partnerships that we have and continue to progress. So thank you.
Yeah, well, we appreciate your work and always here to partner on projects.
Wonderful. Thank you, Amanda.
Yep. Take care.
You too.
Good night. Thanks, everyone.